Hi there, welcome back. Introduction to reactors. We are still on the introduction phase, but I want us to familiarize ourselves with the general mole balance and equations, also with different notations that are used to make your lives easier moving on forward. We are going to look at a general mole balance. This is just a generic mole balance. Do not mind certain variables used, such as J. You'll notice that other textbooks might refer to A or J. I am going to work with J for this example here. Let's look at the scenario here. We have that which is flowing in, generated, and that which is going out. We know that the general mole balance states that accumulation is equals to what goes in, subtracting what goes out, and the rate generated. Hence, I'm going to present everything in this format here. This being my accumulation, that which is going in, going out, and generated. Generated can be expressed in the form of rate multiplied by volume, with the units respectively. If we divide the system into smaller subunits, we can represent it in this format here. This generated can also be represented in the form of its integral, represented here in equation 2. So my first equation is the general mole balance, and this will be my second equation. If you substitute equation 1 into 2, you will get this equation here. What we simply did is we replaced G by this variable here, and that would be your general mole balance. Now let's look at a batch reactor. Continue with the symbols that I was using earlier on. First, let's recap what we just derived. We said our general mole balance can be presented in this format here. Now let's specifically derive for a batch reactor. A batch reactor does not have any flow, so this means my flow rate in and flow rate out will be 0. We will be left with accumulation and generate represented as here. For a constant volume, we can derive the batch reactor formula in this format here, and for a constant pressure, we can derive it in this format here. Let us look at our continuous state reactor where there's continuous flow of in and out. So in this case, we do have flow in and flow out, but unfortunately, accumulation here will be equal to 0. Recapping on the general mole balance, we say the expression can be in this format here, but now in the case of continuous state reactor, our accumulation will be equal to 0. Hence, we can remove this from our equation and can be expressed in this format here. We can change the expression of rate generated from its integral format into this expression here. If you make volume the subject of the formula, we can derive this equation here. To not confuse you, a volume with an apostrophe of a dot is the same as Q or volume to a sub-zero. This simply means it is a volumetric flow rate. So it's volume at a time. The ratio of volume per volumetric flow rate can be called space-time, and it's basically volume over its volumetric flow rate. And there you go, ladies and gentlemen. We just went through general mole balance, batch reactor balance, and a continuous state tank reactor balance.